Hi everyone, my name is Ayush, and in this video we are going to solve the problem that is unique paths. So this is the medium problem on lead code, and trust me on that, if we able to solve this problem we will be able to solve most of the patterns on recursion, and recursion is most important topic on DSA. So let's start with the problem. So there's a robot on M2N grid, okay, and the robot is initially located at the top left corner, that is grid 00. So starting position of the robot is given. The robot tries to move to the bottom right corner, which is the final position, which is grid M-1 N-1, right? The robot can only move either down direction or either he can take right direction, right? Given the two integers, that is m and n. So m will be the size of the row and n will be the size of the column. Return the number of possible unique paths that the robot can take to reach the bottom right corner. So what we need to return? We need to return the total number of possible paths this robot can take to reach the final position, which is bottom right corner, right? Now, and also this is given that the test cases are generated so that the answer will be less than or equal to 2 into 10 raised to power 9. So let's see the example 1. So this is the starting position, that is 0 0, where robot is standing, and he is either can go to right direction or either he can go to down direction. And this is the final position, which is m-1 and n-1, where robot wants to go, right? And what we need to return? We need to return the total number of paths. So let's see with our example. So I've created this small matrix, and this is our robot, right? And what he can do, like he can either go to right direction or either he can go to down direction, and he wants to go to this final position. This is the goal of the robot. Now, what are the possible paths? This is one possible path, right? This is one possible path, right? And this robot can take this path to reach his goal, and also this robot can take this path to reach his goal. Now, whenever this comes like to explore all the path, or like we need to return total number of paths, right? So for returning the total number of paths, we need to explore the paths, like all the paths we need to explore. So whenever this situation arrives where you need to explore all the paths, what we use recursion. Yes. And what is recursion? Like in recursion we just call the function again and again, and there's some index which reduces itself or increases itself till it reaches to the final position, right? So in recursion always there is a base condition. So suppose this is the position of the row, that is I, and this is the position of the column, that is j is the position of the column. Now, so let's make the base condition here. So if the robot reaches this m-1, like m-1 and n-1, right? So j will be equal to n-1, then this is the final position that robot reached, right? So if he achieved his goal, what we will return? We will simply return 1, because one possible path we have achieved. So we will simply return 1. Now, suppose this robot is standing here. So from here, what are the directions are allowed? He can either go to right direction or either he can go to down direction, right? But from here he cannot go to right direction because this is the end of the row, or sorry, this is the end of the column, right? So he cannot go to right direction, so he is only allowed to go down direction. And similarly, if robot is standing here, he cannot go to this down direction because this is the end of the row, so he is only allowed to go to right direction. So you need to understand the boundary of this matrix. So this is the boundary, this is the boundary, right? Like this is also the boundary. Like if robot is standing here, he cannot go to right direction, he can only go to down direction. So what is the boundary? Like he cannot like he cannot cross the n minus 1 thing. Like I j should not be greater than n minus 1, and similarly I should not be greater than m minus 1. So for that we need to have a if condition, right? To avoid this like wrong things, we can use this if condition. So there like we need to have a check that if I is greater than m minus 1, and we will use this uh, or, right? Because any either, like if it is like moving to the row position, if it is crossing the m minus 1, then that is also wrong. Or if j is crossing the n minus 1, then that is also wrong, right? So suppose if it is going to the wrong direction, so we will simply return the 0. Okay, so this is done. And what are the positions, like not positions, what are the directions this robot are allowed? He can either go to right direction, or either he can go to down direction, right? So suppose robot is standing here and he is going to this right direction. What we are doing, we are increasing the size of the column, right? So this is the initial position, like 0 0. So if he is going to this right direction, we are increasing the position of the column by 1, right? If it goes to this direction, we will increase 0 comma 2 by 1. And similarly, if robot is standing here and he is going to this down direction, what we are doing, we are increasing the size of the row, that is 1 comma 0. And similarly, if it goes down again, then we will increase by 1 again, and 2 comma 0 it become, right? So we'll call the function, and we will increase the size of the column, right? The row size will remain same, and we will increase the column size by 1. And similarly, if it goes down, we'll call the function again, and we will increase the size of the row by 1, and the column size will remain as it is, right? So that's it. Now at last, what we need to return, we need to return the total number of paths, right? So for returning the total number of paths, what we can do, we can add it up, right? We will simply return the right plus down. So this is only like thing that we need to solve, and this will be our solution. So let's solve this problem by using this solution. So if you see, like at 14th line, this function is already given, right? And I have called the function that is recur with the name of recur, and the initial position of the robot is 0 0, right? And with that, I'm also using this size of the row and column, because at last we need this for calling our this base condition, right? So let's come to this recursion function, what we are doing. So first is the base condition, that like at 4th line, if you see, this is a base condition, right? So here we are returning 1, like if it reaches to the base condition means final goal, then we will simply return 1, right, for the one possible path. And for avoiding that, suppose if it crosses the m minus 1 or it crosses the n minus 1, then we will simply return 0 to avoid wrong direction. And at 10th, we have defined this right and down. Like if it goes to the right direction, that means it is like we will increase the column position by 1, and if it goes to the down direction, we will increase the row position by 1. and at last we'll simply return this right plus down by adding it. So let's see this solution works or not. So this is not optimized. So if I run the solution, so this is working fine till here, but if I submit this, you will see this time limit exited. Yeah. So the reason is for time limit exited is this is not optimized. We are using the overlapping things. So we will understand how we are doing that. So how to optimize this, we will understand. So let's optimize the solution. So suppose our robot is standing here, and this is one possible path, and this is also one possible path, and also this is one possible one, and this is also one possible path. So if you see in this cell, we are the cell is overlapping, right? If robot comes from here also, this is meeting this cell. If robot comes from here also, this is meeting this cell. Now let's take this cell, right? So suppose the robot is standing here. What are the possible ways from here? He can either go to right direction or either he can go to down direction, right? So suppose if robot goes to this direction, so from here, what are the possible path? He can, if he choose this direction, he will get one possible path, and if robot choose this direction, he will also get one possible path. So this one, which adds up, and it will give me 2, right? So this cell is giving 2. So that we know, like from here, so if we come, this cell is going to give 2, and suppose from here also if we come, the cell is going to give 2, right? So if we able to store that value 2 somewhere, then we don't need to repeat the process again and again. Like we will simply from here we can get the 2 and we will just return it, right? We don't need to follow the process going down and this right again and again. So this will save the time, right? So for storing the values on this, DP comes into the picture. So what is DP? So DP is dynamic programming, which stores the value, like pre-stores the value, and it avoids the overlapping for recursion, right? So how it works? So DP, it works like first we need to define the DP. So for DP, like how can we define? Like we need to define the 2D vector, right? 2D vector, or simply we can define 2D arrays, but vector is good. And like for each cell, suppose we are defining this vector, 2D vector. So for each cell, we have to store -1 value initially. Initially, we need to store -1 for all cells. And suppose at any cell we have already, like for this cell, suppose we have already calculated its way and we got 2, right? So we have stored 2 in this for this particular cell. So second step is to store the values for all the cells, and third is to check if dp of I and j is not equal to -1. That means we have already traveled from that particular cell. So if we already travel from this particular cell, then why we are repeating the process again and again? Just simply return it, no? Simply return that pre-stored value, right? dp of I and j, simply return it. So that's it. So this is the process, and that's it. So let's see the code. So this is the code for it. So what we have done, we have all we already. So I have already wrote my code. So this is the DP code. So if you see here, I've only added 3 lines. Yes. So for defining, if you see the 18th line, I have defined the dp 2D vector, and initially the value is -1. Now, if you come to the 10th line, here I am checking I've already traveled that cell or not. If I have already traveled that cell and already stored the value, then I will just simply return that value. And if you see the 15th line, that third line that I have added is to store the value. Okay, so whatever the value we will return, we will store in the dp for that particular cell. So let's see this solution works or not. So let's submit it directly. Yeah, so you can see that the solution works fine. So yeah, that's it. Thank you for watching.